G'day guys, welcome back to the channel. Today we've got a Yamaha mixer for repair. Now the customer told me this one doesn't work, doesn't power on or do anything. It's one of those. I haven't had a look at this at all yet. What's that? A 600i by the look of that. Portable PA system. Okay, just a little powered mixer. Not much on the back of it. It says there's a USB port there, but that doesn't look like much of a USB port. Is the one on the front? Yes, there is. Okay. So that's just the output there. Otherwise, obviously for your phone or some other USB device, a Bluetooth receiver or something like that. So anyway, there's not much to this. There's a bit of a look at the front. It's just a standard format mixer. Okay, so now what's this? Okay, obviously goes on maybe a tripod stand or something like that. Now, to get this apart, I'm just having a bit of a look. We'll get something to sit this on. Looks like there's 8 screws, 10 screws. There's 4 down each side, 1 on either end. So yeah, that's it. Now, before we go any further, I've got a plug here. I'll just plug in the other end, and that is off at the moment. Let's plug it in and see what happens. Turn him on. Nothing. Certainly nothing. The man is right. There is no operation whatsoever. Okay, time to take the back off, have a look what's inside. This has probably got a switch mode power supply in it. I'm not sure. It's fairly, there's a bit of weight there, but yeah, it might be a linear supply. But anyway, I'll get something to sit this on. We'll get the back off. Okay, let's lift the back off. Not much in there, bit of dust. Too bad. Now, what have we got here? Looks like a switch mode supply, doesn't it? In there. Okay, so to get the cover off this, 4 screws and that one. So those two on the outside, 4 on here, and I think the cover may come off. Just not real sure with this one. I'm getting my hands in the road there where the camera is. So one thing's for sure, these two have to come off. They're just threaded screws, the ones in here. These ones, well, will be obviously threaded as well. Do I have to take them off? I'm not sure. I'll take this one off first. Now this is a first for me, this Yamaha little PA system. I've never dealt with one of these before. I would say these must mount onto some arrangement under there somewhere. Don't know whether, just move the camera back a bit. My lighting, there we go. Just trying to adjust my lighting there for you. Okay. What will this reveal? Nothing. How did I know that? Probably you fellas are out there screaming out at me, Baz, unscrew this and unscrew that. But I can't hear you. Okay. I'm not exactly sure how this is supposed to come off. These two? I think so. That one. This one. And this one. Okay. Ah, something's moving here now. Okay. We got the same on the other side? Yes, we have. Okay. 3 along there that actually screw into the circuit boards. We'll get him out. Right. Few screws there for a while. Now, there we go. Right. Whoa. Gee whiz, this thing has got some gear in it. Okay. There is a lot of gear in this. Obviously the amp, probably a DC to DC supply of some description. No, that's actually the main supply, because this is just filtered input. Give us a bit of a look there. That's just filtering everything on the input. And of course, that fuse, you know me and fuses, we'll check that before we go too far with it. Little fan in there, we'll have to check him to see. No, he seems to be springing okay there, polling okay. He seems right. So, this is obviously the power supply and part of the amp, or it is the amp, or yeah, this is a crazy piece of gear. Okay, first things, fuse. Let's check him out and see if he's okay. All right, and there we go. Blown fuse. What size fuse is he? It is a 6.3. I think I'll just put it under my Maggie lamp. Yeah, it's a 6.3 amp, so that's a fairly hefty fuse. So I would say if that's blown, something may something more in here, other than a bit of a power surge or something. Yeah, something may have gone bang. But anyway, we'll check out a few things now. I'm just I have to move something here. Move this out of the road. Okay. Bridge rectifier. Is it here? No. So it comes into here. That looks like a relay, although it could be a bridge. No, it's a relay. Probably a soft start relay. I'm not sure, guys. I don't know. I don't know where everything is with this. Just looking for the bridge. And, well, we need to measure across that cap to see what's happening, to see if there's any shorts. Okay. Not down in there anywhere. Where is the bridge? Rectifiers. Okay. I would say this is your input circuitry, and this obviously a chopper transformer with yeah, these are 63 volt, these caps, so this would be your output, probably a 50 volt rail, something like that. Anyway, here I'm only guessing, so you can correct me on any of this, because I've never attempted one of these. Now, getting this apart is we take the fan out. These boards, well, the end board comes off, connector there, couple of screws, it comes off. These side boards can come off, and that way we can unscrew the board, the whole board, and lift it out. We're going to have to get it out. If I can find the bridge rectifier all underneath this, I can work out whether this thing's got a dead short on it or not. Now, what happens here? Something. This may get us to the top of something here, that's all. Or it may not get us anywhere. There's a little screw down in there. Pretty sure he goes through to the front. And yes, he does. Look at that. Okay. I thought I may see something Under here, no, can't see that. Now, in under here, we have some diodes or MOSFETs or something along here. Guys, I'm going to go and see can I download a circuit with this quickly, and just to give me an idea of where things are, just where everything is. I don't think we have to take the front off. I'm not real sure. Our mixer's in here, but all our power seems to be on the back of this. Let me go and get see if I can get a quick circuit, and it may help me. This might save a bit of time. Right, guys, well, I've downloaded a circuit for this. Now, we're starting by looking for the bridge, and it's actually under the board here, and it's screwed down to the heatsink on the back. It's the 4 in a row just in there. Now it's D103. So I'll pull him around. I'll probably I'll get something underneath this, and so you guys can see what's going on. I'm going to see that possibly. I'll bring this down a little bit closer. A bit jerky there. Okay. Now, what I'm looking for is D103, and I'm looking for a short circuit there. So I'll try and get my hands around here so you guys can see. That's a negative on this side over here, and we've got a diode junction there, one there, one there. Now, swap these leads around, nothing there, nothing there. If I can keep on it. Okay, nothing there. 157. There's a junction there. This one is on a cap that's going up. So certainly between the negative here and the positive, there is no sign of a short circuit. Okay, so that's good. Now the next thing we're going to look for, I'll show you a diagram of that. There it is there on the screen. You can see where I'm checking there, D103. So just across the positive and the negative, just to see if there's any shorts in that area. Now, the other two transistors that I want to look at, okay, is the Q107 and 108. And there's the diagram there. You can see what I'm looking at with those two. A couple of MOSFETs, one, especially 107, a fairly strange looking job. Now, I'll just gotta bring this back into line there, get this thing out of the light somehow. There we go. Okay, 107 across it. Nothing there. We have a junction there. And nothing there. There's nothing wrong with that one. 108. We have a dead short. There we go. There's the problem, guys. That is a dead short across 108. Right, there's our problem. That's what would have blown the fuse. What's caused that? Well, yeah, we don't know yet. Okay, what I've got to do is get this board out. So let's get on and do that. I was hoping I'd get away with maybe a bit of a power surge or something like that, but no, it's certainly not that. Now we'll start by undoing the end board, which is our power board, power input filtering. This one. So this board's got to be got out of the road first of all and unplugged from the main board. So we'll get him off first. We're going to have to look into the circuit a bit to find out how it all works and why that MOSFET would be shorted. The big fella seems okay, as I said, but you never know. Something has caused this thing to go bang. There's screws in this fella to hold him together. I'm probably undoing more than what I should. Anyway, we've got to get into him. Gee, this is a long screw. That one. All these ones up the top here, fairly long. Rightio. Right. There we go. The board's actually fallen out. That's good. Now, we've got a plug there, which is our AC input to our main board from this fella. And obviously a bit of feedback here from power good or whatever's happening there. And another little filtering board down here, which I don't know what it does, but it could be anything. Now, what comes next, guys? Oh dear. So that fella. Oh, okay. This is our speaker output from this board, which comes up here somewhere. Okay. So we'll have to undo these fellas. Right. And comes off there. What else is holding this? One screw, USB, a USB output. There we go. There's our speaker, external speaker output board. A couple of nice little ferrite coils there, in line with the speaker, obviously. Okay, so we've got everything out of there. The next thing we've got to get is the fan module out of the center, which is pretty easy. Very easy. Maybe I shouldn't have said it was very easy. Okay, unplugging. And the fan could do with a bit of a clean up as well. It's fairly dirty, but certainly not what's caused this problem. Possibly a power surge or something like that. Okay, the next board I see, which has got to come out, is this one. Because it's mounted to the front board, we need to get this board up. No, we mightn't have to take this one out. I think there's a little little connector here, and he pops out. Okay, so now we've got to get this board, the whole lot, out. So what we've got to do now, if you're following along with me or got one of these or know all about it, every bloody screw you can see, I'm guessing. But they do have little screw symbols next to them, which would obviously indicate they're the ones you've got to take out. Okay, so as I said, I think it's every single one. Okay, I'll get them out. We'll come back. Righto, guys. Well, I've got all the screws out, but yeah, I was wrong about not having to take this little board out because this connector down here is onto the board. And what does this board connect to? Blimey, don't tell me I've got to take the front off this thing to get this board out. It almost looks like it, because I can't really lift that one up out of the road. That's not going to work. I think I'm going to have to somehow. There's got to be a way of doing this. The rest of the board, I'm thinking, yeah, the rest of the board is ready to come out. It's that plug there that's holding it. Okay, what's that screw? No. Surely not. Does it look like it, doesn't it? Oh, guys, have to get this one off first, I think. Ah, yes. There we go. Just two push-on connectors. Okay. Now we can get this board out. Now this board on this side is pretty well the same. Will that lift? Yes, that lifts out. That's good. Okay, now we're back to a flat board. And I must say, a very heavy board. Lots of things here to get out. Hey, just a little plastic clip. And there we go. Okay. um. Oh. Oh dear. Um. Yeah. Okay, guys. Well, this is a beauty, eh? Give us a nice close look at that. Yeah. Well, she went bang. She did. There's your bridge under there. Yeah, there's nothing wrong with the bridge. And where that is very, very black, it's back. It's back over underneath the capacitor. I'd say this has had a very high energy spike. I'm not real sure, but this one is shorted. This one seems okay, but this is only the beginning. We've got to clean this up. That's actually directly underneath the capacitor. Now, I'll give us a close look there. I don't know quite what's underneath that capacitor. I don't know whether it's resistors, bleed resistors, or what it is. We can have a look at this now anyway on the circuit. So, yeah. All right. So that's the damage. Why do I get jobs like this? Anyway, we've got to get it going. There's a little diode here, and he seems to have a little bubble on him, and I'd say he's finished as well. Can't quite get a good zoom on him, but yeah. Right. Well, guys, I'll clean up and get rid of a bit of the stuff here. Get rid of me towel from underneath this, and get some cleaning fluid and try and see what's underneath this Big Bang Theory. Let's have a look on the circuit and see what it is. Right, guys. Well, looking at the circuit there, you can see the capacitor's actually in the middle. I've got a circle around him. He's C116. It's a 680 microfarad, 400 volt. Now, it does have bleed resistors across it, but they're all 330k. You can see the four of those in this slide. And there's also some, they're just dropping resistors for what looks like a soft start network of some description. I don't want to go into the operation of the power supply, although I may have to before I can fix this. So there is. It actually says 1/10 of a watt. So they're only very small bleed resistors, 330k, or is it 10 watt? I don't think so. It comes across as 1/10 of a watt. So that is 137, 136, 135, and 134. Okay, so that's the main filter cap, and of course that's on the main B plus line to our Q107, the actual chopper itself. This will be interesting. And Q108, that F25F 60 CPM, that's a little MOSFET there. I haven't got the full circuit. I'm watching what you're watching there at the moment. So we're going to have to work this one out. And of course, I will have to order parts for this. So we need to find everything that we need right now while we're doing this before we order any parts. I certainly don't have these FET transistors in stock. The top one, that top one there, the FDPF 10 N60 ZUT. Yeah, very odd looking MOSFET, although it's probably common in lots of things. I haven't come across it before. Alrighty, so that's where we're up to. I'll get back in here now and let's clean this up, get all this, yeah, see what's under here, see why this went bang. What's the go here? Was it a power surge? Is it something that happens with them? Let's check it out. Okay, so initially I'm just using a little bit of methylated spirits on this to get rid of the rubbish off it to start with. It mightn't be as bad underneath as what it looks initially, but something under here has certainly shorted and gone bang. As you can see, it's not near as bad as what it first appeared. I'm not saying the fault, the actual problem with it isn't real bad. It's just what's been burnt isn't that bad. This is going to be a bit of a fix, I think. And normally Yamaha gear, well, normally it's pretty good. I have no problems with it. Not that you say too much about anything on YouTube, do we, these days? Get you into trouble. Get your copyright strikes and all sorts of all sorts of things. We don't want that. It's coming off okay. Coming off quite nicely. Most of these resistors are burnt up. Now this sort of indicates a voltage surge, maybe used with a generator, possibly. Not saying it was, but it's a possibility. Or a very nasty lightning strike power surge that's taken a fair few things out. I'll give you a closer look at this when I get this done. We also need some new insulating material for the FETs, and of course, well, I think I'd be replacing the FETs anyway. There's been a bit of stress going on when all this was going on, so yeah, I'll just move that. That's looking a little bit better. Nowhere near as black. And well, what could we say? The problem's not near as big as what we thought it was. Yeah, that's how it looks. Not always that's the case. All right, now I'll get a little bit of IPA, some isopropyl alcohol, and finish the board off, and then we'll start looking into how many things in this area have been destroyed. I'll grab my alcohol if I haven't drank it all. Okay, now guys, this is IPA, isopropyl alcohol. It is not the stuff you drink. Never drink this stuff. You'll end up in a pretty bad way. There we go. have a trace down the fault here as to what happened, what went bang. But the way it looks, power surge, and well, it could be it won't be the cap, but of course we've got to remove the cap and check it. And well, the pins on the cap appear to be 2 here and 4 here. No, I'm looking in the wrong place. It's this one and this one. Okay, all these are destroyed. Okay, so they're just across the cap, which, yeah, sort of indicates to me a lot of voltage across there, and it's taken these out. A spike or, yeah, something very similar to that. Righto, I'll let that dry a bit, and then we'll brush off all the white stuff off it. There it is. A bit yucky. Yeah, that'll all come off okay. Okay, we'll do that, and I'll come back. I'll set the board up where we can work on it and start doing some checks. Right, guys. Now, I've got him sitting on an angle there where I can sort of work on him. Now, there's our capacitor across the cap. And as you can see, there's no... Yeah, no, that's just the cap charging, discharging. There's no problems there. Now, these little fellas, the resistors, they look like totally burnt out. Let's see. 3 meg, that's a bit high for a 300k. 2.8 and 2.5, 5.6k maybe. And I'm only doing this as procedure. 5.8, so the bottom 3 may be okay. But of course, they'll be replaced. The FETs, that one, well, he's measuring, let's put it on diode test, eh? And he is more or less dead short. Okay, that's that fella. That's Q108. Q107, which is the fancy one, actually reads okay. Yeah, actually reads okay. But of course, I'll be replacing the pair of those. That's a diode. This is a diode on here. No problems there. And of course, across our bridge, well, yeah, we've got our, yeah, the bridge is okay. Now, we've got lots of little other things that that are in this circuit. There's a few little things in here that actually engages a relay. But we service mount stuff, eh? Let's see here. Can't get... I think this is a digital transistor, actually. So it probably won't measure. I'll have to do this with the circuit in front of me. What are these resistors? What are they measuring? 100 ohm, 109. They're actually a 221, so 200 ohm, 109. But I think these are in parallel, which would make... Yeah, they are in parallel. So they're 200 ohm in parallel, and then they're series together, I think, from there to there. No, possibly not. I think they're all parallel, the 4 of them. Anyway, once again, we'll have a look at the circuit. 470, yep, 47 ohm. This one, 47 ohm. There's a little diode here. Diode check. And see if he's got a junction there. Yes, he has. Now, this fella over here that looked a bit sus. And no, he's okay. There's a few little caps around there that we can check out. There's a couple of transistors up in this area here. Once again, I'll have to sit down with a circuit and go through these. I can't do that with this setup at the moment, but I can certainly guide you through what I'm doing and yeah, going from there. This says D104, so obviously a diode, and 0.3, it's probably a Schottky. 0.3, so yeah, I'm not real sure about that one. I'll have a look at what it is. There's another one up here, and there's my phone. Okay, 0.6, he seems okay. Very hard without the circuit in front of me. I'm going to have to round up the main thing. I did print it out, and believe it or not, you just can't read the print. 0.3 and open. That's probably a Schottky as well as the one over here. These are voltage regulators. That's on the output of the transformer. This blow up is on the input. So I doubt very much whether anything down the track is blown up here. There was no short evident on the rails going to the power amp, so I don't think there's any real problems. But now I'm going to put it under the microscope, go through these, and let you know what I find. Nothing obvious yet, other than that one, these, and well, I'd replace that as well. Right, guys, now this is probably a month later on this thing. I've had to put it aside, and we've been having lots and lots of hassles looking up parts for this thing, which I've eventually found. For a while there, they were not available, but now apparently they are. But anyway, what I've found, now, we know these are crook. I'm just, well, this one anyway, which is Q108, and our resistors. Now, on the other side of this board, you've got some feed resistors for your PWM chip down here. Now, these little fellas are down here. Now, where are we? We've got R140, 143, 145, 150. They're all 4.7 ohm. They are all open circuit. Now, they feed down, actually, to the PWM chip. Now, it's a UCC 2893. I'll just flick the circuit up, and you can, might be a little bit easier than having a look at this. But as you can see, I'll just circle the resistors in question. Now, I'll just hold this still. So R140, 143, 145 are all open circuit. Now, there's D11 that's reading short circuit. But 145 the resistor may be okay. So I'm going to have to lift that, probably the resistor out, because I'll be replacing all of those, and then recheck the diode D111, and also the coil there, L102. I don't know whether it, I did check it. I can't remember whether it's any good or not. On our circuit board here, now I'm holding it this way up. Okay, our PWM circuit's in here. Now L102 is right there. Okay, you can see him there. So our little resistors, along this line here are open, but as I said, well, R145, I don't know whether it's open or whether the diode's shorted, so we've got to check that out. The chip, has it damaged the chip? We really don't know. I'm going to replace the chip anyway. I'm not going to, that chip has been pretty badly stressed. Obviously the power has run back through, we'll go back to the circuit there, through whatever's happened up the top there, and it's run back through the 4.7s when the MOSFET has shorted out, and right down to pin, 13, the output of IC 101, which is the UCC 2893. The chip may be okay. I'm not going to chance anything there, because it's also driving the top MOSFET, which is Q107. Now there's a bit of a gate arrangement with him. D109, you can see up the top there. R142, 144 and L101 do measure okay, but of course the D109 is reading short circuit because of the two 4.7s that are across it. So I've just got a little bit more investigation on what I've got to do with that, and well, for a start I'll remove both these MOSFETs. We're going to have a look at them, well, we know this one's shorted. I don't know about this one. This is the top one, which is Q107, and it's a 10N60. Okay, that's a 10N60, and this one is a 25F60. Just, they've got other numbers, but we'll run through that when we get further along. Along this side of the board, I can't see anything wrong in the regulators or anything. It's just, the worry is this little piece here, our PWM circuit. If that fails, those MOSFETs blow up. Okay, so simple as that. All right, I'm going to remove these and, well, see what we find, because some of our measurements will change once I've got rid of this short. Okay, I'll remove him and I'll be back. Okay, well, we've got both these out. Now, this one is the 25F60. Now, this is the one that did read short circuit. Let's see what it reads out. Yes. Now, that's from gate to source, and gate to drain is dead short. Everything is short. Dead short. So that fella definitely took the brunt of the whole thing. Now this is the other one. Now this is the 10N60, the top MOSFET on that circuit. Nothing. Now we should be able to trigger this into conduction. Can I do this? No, it won't. Okay, I'll just get my other little checker. That's not, well, not reading real good actually. Let's see what this little fella reads. I don't know whether this will do MOSFETs. I really don't know. Okay, let's go here. So, that one, and the middle one. That's right. Now the source, and let's see what he reads. Oh, it does read okay. There you go. So RD on is 1.5, RDS on 1.5 ohm, which is the specs on him, or what it tells me. So we need roughly to turn him on 4.6 volts. Let's do that again. He faded out. 4.46 is minimum turn on, and the RDS on is 1.4 ohm. So, yeah, there's nothing special about that MOSFET, but the thing is, he's okay. All right, so that's our main driver, which is this fella up here. That's our the workhorse of the whole power supply. This little fella, well, he's monitoring current and yeah, and everything else down below here as far as voltage selection and all sorts of things. I'm not going to go into the theory. I don't know a lot of this theory without going through and reading it, but I can sort of see roughly how this works. We don't need to know the theory to get this thing working. It helps, but we don't need it. Okay, so that's the one I've taken out and it's dead short. This fella's fine. Now I'm going to take out that little, this series of 4.7 ohm resistors, and I'm also going to check L102. Okay, I'll keep the camera rolling while I do this. And L102, if I look on the board, and you won't be able to see this on the camera. I mean, it's surface mount. Geez, I hate surface mount. Okay. Probably because I don't deal with it a lot. L102. There he is there. He's right there. You guys can't see him. L102 is 2.9 ohm. He should be okay. .82 ohm. Okay, so that means he's okay. Now what I've got to take out, as I just said, 140, 143, 145, because they're all burnt. So 140, 143, 145. Actually, there's R150 there. What is R150? It's a 22K. Let's measure him and see if he reads. Where is he? These are pretty small. There he is. 22K. Okay, so I'll remove these, then we'll check the diode, D111. Right guys, now the picture may be a little bit blurry there, zoomed up, the camera's not real good on close stuff. Of course I'm using my secure tweezers. If you guys need these, secure. Okay, just Google them. I did a review on these, HT140, and wow, they are just great. Well, I don't know how you do this without this. So here we go for resistor 140. There we go. Now you can see the size of the bloody resistor. It's on the end of there. Now I've got to get him off. Now these are open circuit. There we go. Now, you probably can't see that in the camera because I'm zoomed in. Okay, so that's 140 out. We've got 143, which we're going to do now. And he's out. There he is. Okay, these are 4.7 ohms, these fellas. We've got 145. Which is right there. And he's out. These take a little bit of using for a while, but after you get used to them, they're not too bad. And I think that's it, isn't it? We've only got 3. 140, 143, 145. Yes. Okay. Now, down here, there's that diode, D111. There's the coil. So we can now test the diode and just recheck that coil. And, well, we've got to put surface mount resistors back in there. Okay, so I will just put my little secure tweezers over the back there. Okay, now I better back this off on the zoom a little bit there, just to get this back into reality. Here we go. Okay. And I'll move this back a little bit there. There we go. Okay. Let's check our diode, D111. And no, it's not shorted. Okay, let's go to diode test. Yes. And this way, non-conducting. Okay, doesn't conduct that way. And we do a forward bias there, and 0.4. So it's a normal diode, it's not a Schottky. Although it could be a Schottky. 0.5. No, I'd say it's a normal diode. A Schottky would be 0.2, 0.3. With my trusty secure tweezers, we've got to remove these big fellas on the back here. This should be quite an easy job, but I need something to sit this upon. What have I got? My little tester. There we go. Look at that, designed for the job. Okay, let's get these off. Okay, 147 is coming off. And these are a little bit bigger, so may take a little bit longer. There we go. That's the one. And yeah, needs a bit of heat on the back end there. Actually, this one's wanting to fall apart. There we go. And next one. There. This one. Okay. This one. How would you do these without these tweezers? I mean, these are great. I know I keep saying they're good, but for surface mount, it just makes the job doable. Whereas otherwise, it's very, very difficult to do something like this with a normal iron. And if you want a pair of these, have a look at the video that I reviewed them. All the info is in there, including in the description. I don't make any money out of these. They were given to me to review, and I don't get any commissions, nor do I have anything to do with Secure, other than using their gear. There we go. Okay, they're actually falling apart. So, there we go. This is what we know so far. Now, I'm going to do a few more tests on this and come back. We can turn this off now. And he stops, and now he's counting down. Yeah, we'll do some investigation just on other things around. We'll do some cleaning here of the solder off this and prepare it. I do have some solder paste here that we'll be using to put these back on, and the same on this side where the other 3 resistors were. Okay, I'll do that. I'll be back. Right, well guys, I've been through this thing pretty damn well. Now, we've found, well, something else odd. Let's look at the diagram. I'm replacing the chip. Okay, this is just a diagram, a rough diagram. R124 there. Now that's an 820 ohm resistor circuit, and probably no doubt because it runs back along here, and actually goes up to where the fellas destroy themselves. Okay, so just a feed resistor to the chip. So the chip's had a bit of a jolt through there. I'm replacing it anyway. The other thing is the feed resistors here are all very, very high. Now, they're around 330 k's, so all 330s running from the rail up here down to this fellow along here. Now, the chip gets its voltage on pin 16 in there from up here. Okay, so we've got these feed resistors here fitting it. There's most of these are 8 to 900 k. So there's 4 of them there. I removed them and checked them, and they're all reading the same, 8 to 900 k. So they need replacing 4 of them. 330 k's for which is 137, 129, 130, and 134. Okay, so there it is. 3 resistors along here, all your sensor resistors in here, and of course the MOSFET. That's it, guys. So far, I've removed the chip with the tweezers. I didn't record that, I knew that. I needed my head up about me to see what I was doing. So there's another little resistor in here, which is 127. That's what I was talking about. No, it's not. No, it's not. Hang on a minute. 127. Okay, here we go. 127 here is a 68k resistor off tip as well. I haven't marked that one. Just 1 moment. There we go. So, one more, which is that resistor. Okay, it goes into some slope. Well, I don't know how this chip works. It's a complicated little file for the size of the chip.
Okay, just on top of my big finger there. Okay, so that's where our tip goes. And yes, where that gap is on this side, there's no pin. Okay, so pin 5 is there, and it's not used. So it's not, it hasn't lifted the tracks or anything. Actually, those tracks, as they are, they're only just look like a couple of them, especially here, a bit up just a little bit. But, guys, that's how it is on the circuit board. Those tracks have not moved. I was pretty careful taking them out. Okay, and the other side, as follows, and these fellas along here, they're 330Ks. That's it. Alright, I'm going to order parts for this now. We'll continue this once I get parts and hope God it works. I don't know. This may be an exercise where the something wrong that I've missed. I don't think so. I'm going to look back at parts here. Yeah. There's about 10 parts. This is not vintage. They've been at this. So that's it, guys. If you like what I'm doing here, and well, hopefully we get this going once I get some parts. This will take a couple of weeks, maybe 3 weeks from China, so I can't get these gifts in Australia. So we'll see how we go and put it back in. We'll test it. Hopefully, for the owner, anyway, it fires up and works. Okay, if you like what I'm doing here, give us a thumbs up. Please remember to subscribe, hit the bell, you know the bell. And once you hit the bell, it'll tell you when I put the next show up or the next part, whatever comes next. Okay, and if you'd like to buy me a coffee for what I'm doing, if I'm helping anyone or anything like that, it's there. It's the QR code. And all you got to do is put your phone at that, and they get straight to my coffee shop. Okay. All right, guys. We'll catch